Hello everyone.
Hello, am I audible? Kindly confirm. Okay, I think we can start the session now. Enough number of people are there. A kind request to all to join by 3 o'clock itself so that we can start it early. Okay, is the full screen visible? Okay, thank you. Please join by 3 o'clock itself so that there is no need for me to navigate the windows from presentation to Gmeet to admit everyone. Good afternoon. Today we are coming for the live session one on the course CH53 Basic Environmental Engineering and Pollution Abatement. Welcome you all. I am Mahalakshmi S, the research scholar in NIT-Trichy. Today we will see the overview of the week one lectures, and then we will discuss the some assignment problems of this week and the previous course assignment problems. Okay, so far I have admitted everyone in the waiting list. Again, someone is joining. Okay, I have turned on your microphone. If my slide is not visible or you have any query, you can ask in between. Okay, let's start the session. So now welcome you all. This is the live session for this course Basic Environmental Engineering, Pollution and Abatement. This will happen every Saturday 3 to 5. I will handle this live session. This is the same Gmeet link to be used for the upcoming classes also. And all these live sessions will be recorded and uploaded in the YouTube channel. The name is Mahalakshmi S. At the ID Mahalakshmi Shekhar NITT. So now, coming to the lecture one, you have seen the videos uploaded by the professor. It comprises different titles, including the environment and its component. Basically, so environment is the condition in which we live and work. So it is the space where the living organism and all the non-living organisms are accommodated. So it includes the biotic and abiotic components. The biotic components refers to the living organisms, which includes the human beings, animals, and the plants. So the abiotic components or the environmental components, which includes the air, water, and soil. And the next one is the natural interaction and cyclic processes for a clean environment. So this is the interaction. You would have seen the interaction web in your lecture PDFs. So this is the interaction among the living beings and all the abiotic components. And then the society and environmental pollution. So how the society is affecting the environmental characteristics are discussed in this portion. So due to the increasing population, we know now India is the largest populated country. China became the second one, right? So due to the increasing population, the demand is also increasing, so that there exists the depletion of the natural resources and the deforestation, and again the global warming, ozone layer depletion, etc. Next is the environmental pollution and sustainability. What kind of pollution here mentioned is the wastes. Waste is generated and waste disposed of. Generally, these wastes are classified based on the phase. It is classified into three types, which is the solid waste, liquid waste, and gaseous waste. So coming to the solid waste, the solid waste refers to the solid materials, which includes the household waste, all the solid materials. And the liquid waste includes the household discharge, which is the sewage waste, and also the industrial effluents, which are all the liquid categories. And then the gaseous waste, this includes mainly the power plant emissions, the SOx, NOx emissions. Next, the classification of the waste is based on the hazardousness. So, how hazard the waste material again categorized into hazardous and non-hazardous waste materials. First one here, the hazardous materials refers to something which is potentially very toxic to the living beings and also the environment, which includes the radioactive nuclear power plant waste, and then other toxic chemical wastes, which causes the hazards to the living beings and also the environment. And now the non-hazardous waste, they are mainly biodegradable. They are not hazardous to the living beings and also to the environment. Most of the municipal waste materials come under this category, non-hazardous waste materials. Next one is sustainability. Nowadays, sustainability and sustainable development is the major goal for every research work. So, what does the sustainability focuses means? It focuses on meeting the needs of the present without compromising the ability of future generation to meet their needs. That is, for our daily need, we have to use the resources, but effectively we have to use it without overusing it and wasting it, so that the future generation can also use the same resources in the same quality and quantity. So this is what the sustainability means. And here in the environmental aspect, we should not affect the environment also in taking the resources from the environment and also using it. Next is the environmental pollution prevention and control. So here to prevent the pollution of the environment and to control these pollutions, mostly here you have seen about the fossil fuel usage, which is the coal. So while burning the coal and taking the energy from the coal, we are polluting the environment in many ways, using the higher amount of fresh waters in the power plant, and also emitting the gaseous pollutants into the atmosphere. So to avoid all these things, the method of combustion we use can be modified. We can also adapt newer techniques to extract the energy from the environment, and some other things suggested or switching to the renewable energy sources from using the non-renewable energy sources. And next one is the waste treatment. We have to, anyway, the generation of waste count is not going to decrease. Every day, the generation of waste is increasing. So, how effectively we have to treat the waste and the resource recovery? How we can recover some useful products for the future? We have to recover the resources from the waste. We have to effectively use it also. And then the environmental ethics, global imperatives, and environmental laws. All these things will tell you what is the standards and developments which are included in this waste management and all. So here some important people you have to get to know or the SPCB, which is the State Pollution Control Board. Next CPCB, which is the Central Pollution Control Board. Next is MOEFCC, which is Ministry of Environment, Forest, Climate Change. All these are the governing authorities for monitoring the environmental impact. And many courses are discussed at the end of this lecture, which includes the environmental science, environmental engineering, and environmental studies. Apart from this, there is the environmental impact assessment, which is a very important thing. So any industry or any company which is going to start in a larger scale, they have to get the approval from these SPCB, CPCB, MOEFCC based on their size. Like they will be undergoing the different categories. Then after some days only they will get the approval. So this environmental impact assessment will assess the impact of the particular industry over the environmental components like air, water, land, all these things, and also the socio-economic activities. Then only they will get an approval for starting that new industry. Next is the lecture 2. So in this lecture, first thing discussed is the ecology. So you know that ecology is the study of interrelationship between the plant and animals. So that is the plant and animals, how they are depending on each other to sustain in this environment. Next is the ecosystem. So here ecosystem is the collection of all organisms that live in a place with a non-living environment. So we depend not only on the plants but also the soil. We need water, and then we need all the resources from the soil for everyday life also. So this is the ecosystem. So all the organism will also depend upon the non-living environment, that is ecosystem. Then is the biogeochemical cycle. We will see elaborately in the next slide about this water cycle, carbon cycle, nitrogen cycle, and phosphorus cycle. Next is the stable ecosystem. If you see the ecological pyramid, we have already studied this in the lower classes. So the base is the producer. So what is the producer? So here the producer is the plant. So it is going to fix the carbon dioxide from the light energy sources, and through the photosynthesis process, they are going to generate food for the living beings. So here the plants are producing the food, and some plants which does not produce any food also is eaten by some of the animals. So here comes the producers, then the primary consumers, then the secondary consumers, and then the tertiary consumers. And again, all these plants as well as the uh, primary, secondary, tertiary consumers. That is the animals, including the human beings. When all these things die, again they all go into the dead and decay. As a dead and decaying matter, they again go into the soil. So soil is here is the non-living environment. So this is the ecosystem. So the a stable ecosystem refers to the ability of the ecosystem to withstand the external stress. So here the external stress refers to the pollution. How much amount of pollutants are released into the ecosystem. For example, if you take a river, if we are considering the river pollution, we have seen that all the treated waters are again discharged into the rivers, right? So if the discharged water is not up to the level, up to the threshold level, it is still contaminated, and we are discharging into the running river means, then there comes a cycle. So what happens is after certain period of time, so this river will undergo a self purification process, and it will self purify itself, and again the good quality of water will be regenerated in the river. But if we are dumping the higher and higher amount of waste, untreated water into the river, after some time, what happens? It will become non-resistible. Like river cannot regenerate itself, so self-purification process will not occur. So the river water will entirely contaminate it. So this is the example. So the stable ecosystem will refer to the ability, like how
Slides are not
rivers
moving.
can withstand the external stress. Next is the alterations in ecosystem and its restoration. So alteration in ecosystem. So this alteration happens how means it can be a direct change or indirect change. Directly the living beings polluting it, or the indirect changes means because of some democracy and political intervention, science and technology. So those are the indirect changes which are making the alterations in the ecosystem. And then coming to the restoration part, the restoration is again divided into active and passive restoration. So active restoration here refers like actively it should be restored by the people. So we people have to again restore the deployed land, like we have to do afforestation like that. And the passive restoration is it is the natural process. So passive restoration always happens very slowly because naturally the ecosystem is restoring itself. Now, coming to the biogeochemical cycles, we have the water cycle, carbon cycle, nitrogen cycle, phosphorus cycle. Is anybody there? What happened? Any issues are there?
Yes, ma'am. Slides were not moving. Now it is good. Next.
Hello? Introduction slide is not moving. Slides are not moving. Okay, someone could have turned on the mic and let me know, right? 1 minute. I have passed 5 slides. Sorry, I will resolve it. Okay, now I'm presenting the entire screen. Kindly confirm whether the slides are navigating. Can you see the full screen of presentation?
Yes, ma'am. Now we can see.
Could you please confirm at least through the message? Okay. Okay, thank you. Okay, this is what the general information is. This is your Google Meet link, and then this is the YouTube channel name and ID, and then we have seen the overview of lecture 1. So it includes the environmental components and how the natural interaction happens, and then the effect of social activities over the environmental pollution, and then the environmental pollution and its relation with sustainability. Next is the environmental pollution, how to prevent and control it. Then the environmental ethics, global imperatives and environmental laws. Then some important subjects, which are the environmental science, environment engineering, and environmental studies. And next one is the lecture 2 overview. which includes the ecology, ecosystem, biogeochemical cycles, then the stable ecosystem, alterations in ecosystem and its restoration. Till this we have seen it. Okay. Now coming to the biogeochemical cycles, first one is the water cycle. This is a very simple cycle. We know that we are getting the rainfall through the precipitation of the clouds, and again these rainfall, all the waters are going into the water bodies and also to the soil. It is stored as the moisture, and again from these water bodies and soil, these waters are getting evaporated. Through the evaporation process, it is again getting restored into the clouds. And from the plants, through the evapotranspiration process, these are also entering into the clouds. And next one is the carbon cycle. So first the carbon in ocean water can be evaporated and it can get into the atmosphere, and again these carbon can be stored in the rocks, and again from the rocks it can go into the atmosphere, and from atmosphere it can dissolve into the water also. And again, if you see, living organism like plants are also taking up the carbon from the atmosphere for the process photosynthesis. And again, these plants are consumed by the animals, all the living beings in the soil, and it is also entering into the soil directly by carbon sequestration. When the living organisms are dead, again as an organic matter, these are decomposed, and when living organisms are alive through the respiration process, from the soil, the carbon is getting entered into the atmosphere. And again, in the soil, there are fossil fuels. By the combustion process, again, carbon dioxides are again released into the atmosphere. These are the some ways of carbon getting circulated in the ecosystem. Next is the nitrogen cycle. So if you see here, N2 is fixed by some bacteria in the land, and some nitrifying bacteria are again converting the NH3 into NO3 minus through the nitrification process. And these nitrate ions and ammonium ions can be used by the plants. And again, when the ammonium ions through the ammonification process are forming nitrogen dioxide, these are also getting released into the atmosphere. And when nitrate by some denitrifying bacteria, it can also again convert it back into the nitrogen. So this nitrogen gets released into the atmosphere. So now coming here to the phosphorus cycle, this is very simple. So the phosphorus from the rock phosphate, which is from the rocks, is present in the soil as soil phosphate. When the rock phosphate weathers from the rocks, it enters into the soil. And from the soil, when through the water bodies, it can run off. And then in the soil, it can be fixed by the plants. And from plants, animal can fix the phosphates. And again, from the animals, all the other plants and animals, all other living organisms are taking the phosphate. And after dying, so the dead plant and organisms through the microorganisms, again these phosphorus are getting entered into the soil. So this is the phosphorus cycle. Now coming to the lecture 3, if you see this is what the ecosystem provides us. So this is the ecosystem service. It is giving the food, water, air, and all the other things what we require to live on this earth, right? And here, main thing discussed in this lecture 3 is the risk to the water bodies. So the risk can be a natural thing and also through the man-made activities. Some of the items which are risk to the water bodies are the arsenic, fluoride, heavy metals, microbes, non-biodegradable organic things. And some of the important terms discussed here or mentioned in this presentation. First one is the bioconcentration. Based on this, you are also having some problems. So bioconcentration here is the process that results in an organism having a higher concentration of substance than is in its surrounding environmental media, such as water. So it is nothing but the ratio of concentration of X. So this X can be any substance, concentration of X in the organism. Say for example, fish, any aquatic animal, and divided by the concentration of X, the same material in the environment. This is the bioconcentration factor BCF. Next is the bioaccumulation. So accumulation means it is coming together, it is going to accumulate in someone's body. So this is the accumulation of substances such as the pesticides or chemicals, and this bioaccumulation also depends on the rate, how fast it is getting accumulated, and the mode of uptake and duration, how long these substances are intaken by the organism. So all these things are included in this bioaccumulation studies. Next is the biomagnification. So here magnification. Magnification means zooming. So we are zooming in the level of food chain. So here if you see the bioaccumulation of a substance of the food chain by transfer of residues of the substance in smaller organisms that are the food for the larger organism in the chain. So when the smaller organisms are consuming these materials from the plants, say for example, when the smaller organisms are eaten by the larger organism, it is getting transferred through the food chain. So we are magnifying this, how this hazardous substance is transported in the food chain. Next is the risk due to transmission of diseases. And through the intake of these substances, there exist some diseases, right? One is the malaria. It is malaria and dengue through these are vector-borne diseases, and again Ebola and COVID-19. No one will forget this. So all these things are taken up from some substances and it is getting transported through some medium. That is the vector-borne diseases. Next is the lecture 4 overview. Mainly, it talks about the risk management, risk analysis. So first, what is risk? Risk is the probability of an adverse outcome. So if there is anything adversely happening, what is the probability of that adverse outcome when it can happen? Like that, we are calculating it. So the formula is, it is the function of hazard and the exposure. So hazard is the biological, chemical or physical agent in or condition of food with the potential to cause an adverse health effect. It can be biological, chemical or physical agent. If see this example, for example, it is a human hazard means that substance can cause carcinogenicity. Can be a carcinogenic substance, that is, it can cause cancer, and then cardiotoxicity affecting the cardiovascular system. Next is the neurotoxicity, mutagenicity. It can mutate the genes in the human beings. So the substance can possess the human hazard. It is hazardous to the human. Next is the environmental hazard. It is the aquatic toxicity. So it is going to affect the aquatic organism. And then phytotoxicity. So phytotoxicity is mainly substances that affect the plants. And then physical hazard. It is the explosive. Physically, it can hazard anyone by explosive nature or corrosive nature. Because of high pH in the water, the organisms can die. So it is going to physically cause harm to the substances in the environment. And then global hazard. So globally, it is going to affect everyone. So it is some examples of global warming, acid rain, water scarcity or excess water, flooding. All these are some kind of hazards. So we are measuring the hazards as well as the exposure. So exposure is calculated by this formula, which is intensity into frequency into duration. So intensity is the how much that substances is exposed, and then frequency is how often, at what rate, like that, and duration is how long we are being exposed to that substance. So it is the product of all these three things. So risk is the function of hazard and exposure. Now we know what is the different kind of hazards and how exposure is calculated. Next is the risk analysis. If you see why risk analysis is done means it is very good method to avoid the risk, or else we can get some solution for that problem. For that, we are doing the risk analysis. This is to analyze information on undesirable events or process and predict its probability, expected consequences, and then we are doing risk assessment and its management. First is the hazard identification. We are identifying the substance so that we can identify what type of hazard that substance can cause. Next is the risk assessment. So what kind of risk or possible risk can be from that substance. Next is the risk management. We are finding the alternatives, and from the alternatives we can get a solution. And risk communication is to the group of people, all the possibilities are discussed, and finally they can come up with a solution. So this is the overview of lecture 1, 2, 3, 4. Now, okay, one more slide is there. So now the intake rate, and this slide is very important for problem solving. Intake rate. So how much substances we are intaking. So this is the exposure expressed as the mass of a substance contacted per unit body weight per unit time, averaged over a longer period of time. So the formula is intake formula is I is equal to CE into RI into EF into ED divided by dW into AT. So I is the intake and CE is the exposure concentration, how much mg per liter we are intaking. Next is RI is the intake rate and EF is the exposure frequency and ED is the exposure duration. Then BW is the body mass, weight of the average person. And then AT is the averaging time duration. So it is calculated in days. And here we have to note down that for the non-carcinogenic substances, AT is fixed as 365 days per year and 70 years. And for for non-carcinogenic substances, it is AT is equal to ED. ED is the exposure duration. How long it is mentioned, we can take ED and AT as same. And for the carcinogenic substances, it is fixed for 365 days. It is taken in an early basis. So you should note down these two differences to solve the problem. Then the dose response and toxicity assessment. Noel, anyone knows what is Noel? Okay, it is the no observable observed adverse effect level. Like up to this level, the substance is not causing any harm to the environment as well as the living beings. So it is like a threshold limit. There is an optimum range. Beyond that, it will have some adverse effect. Next is the dose response curve over the different dosages. Say for example, 10, 20, 30, 40, 50 what is its intensity in causing the harmness in the living beings, that is measured using the dose response curve. Now coming to the terminology is hazard quotient, which is a HQ. Hazard quotient HQ is equal to I. So this I is calculated from this formula, I non-carcinogenic by RFT. And for the non-carcinogenic or for the non-carcinogens only, we will use the reference dose, and for the carcinogens, we will use the slope factor. And then the hazard index, when more than one substance is causing the hazard at a time, then we have to find the hazard quotient for the individual substance and we have to add them all and we have to find the hazard index, HI. When this HI is greater than 1, then that substance is considered as unsafe. Okay. Now we will move on to the assignment 0. Anyone there waiting to join? Okay. Have you all solved the week 0 assignment? Have you tried it? Have you tried solving it? Answers are already available, right? It is for your practice. First, I'm going to discuss the solution for that week 0 with small information. Okay. So coming to the first question of week 0 assignment, method or methods used for the collection of particulate matter is or are. Identify the most suitable option. So the answer is all of the above, which includes the sedimentation, impingement, electrostatic precipitation. So here they are asking you to choose the collection method for the particulate matter. Where this particulate matter comes from? What is particulate matter? Anyone knows the answer? You can interact. You can also send messages in the chat box. What is particulate matter? No one knows it.
The pollutants who are in air or in water, that matters.
Jay Chaube, you are speaking, but you are not audible.
The pollutants which are
IIT Route 1. Yes, this is the same course. Yes, I have got one answer in the chat. Solid particles suspended in air. Yes, good. So, in the power plants, there will be uh, small, tiny particles which get dispersed, like sulfur dust from ash component. Mainly, all these fly ashes are getting emitted into the ESP chamber. So, those are the one main examples for particulate matter here. So how these things are collected means basically by all the three methods. First one is the sedimentation. We all know what is sedimentation. The main principle behind is the gravity-based settling. So it is suitable only for the larger and heavier particles. Again, someone is waiting. Okay. So it is the for large and heavy particles, suitable for large and heavy particles. Next is the impingement. So the principle here is the collision against the flat surface. If you see that the particle is passed through this opening at a high velocity, it will be circulating here, and that particle will get collide against the flat surface, and it will be collected under this region. So next is the electrostatic precipitation based on the electrostatic forces, right? So the waste gases containing the smooth particles or pass through this ESP chamber. Here the particles will pick up a negative charge since the negatively charged metal grid is here. And when it is surpassing these collecting plates, these particles are getting attracted to these plates, and then the waste gases without the smoke particles will get released. All these particles from the collecting plate will be removed, and later again the next set of gases can be passed over here. So all sedimentation, impingement and electrostatic precipitation methods are coming under the methods used for the collection of particulate matter. Next, the second question is, in proximate analysis, moisture content is measured by drying the sample at what temperature for 24 hours, they are asking. First, what is proximate analysis? Anyone know about this method? What it is used for? Are you familiar with this method? Yes, yes, of course. Vishwajit, you are attending the right course only. Okay, you are not familiar with this method. Okay. First, the proximate analysis. There are two different methods, which is the ultimate analysis and proximate analysis. So, in the 4105, yeah, 105 degrees Celsius is the right answer. So, in the ultimate analysis, what we are doing is we will find the elements. which includes CHNS. So this is measured using the CHNSO analyzer. We can measure the percentage of carbon, hydrogen, nitrogen, and sulfur. Uh, these are the weight percentage. By subtracting all these summation of CHNS from 100, we can measure the oxygen content indirectly. So this is the elemental analysis or what ultimate analysis. And the proximate analysis is for any biomass or for any substances. First, at 105 degrees Celsius, you will be evaporating all the moisture content. Then you will increase the temperature and you will remove the volatile matter, like all the volatile compounds. Volatile compounds are the substances which can burn and they can emit as the gas from the biomass. Next, you will again increase the temperature. After all the volatile matter or evaporating, only the fixed carbon will be there. Finally, when you are increasing the temperature again, what happens is this carbon, fixed carbons will also get react with the air, and they will also released into carbon dioxide. Based on the residence time, your product will be varying. So finally, you will get ash. So for in the proximate analysis, yes, your final exam will also have problems and you will also have the and MCQs like this. Yes. So in the proximate analysis, you will be having the moisture, volatile matter content, and then the fixed carbon and the ash. So this is what you will be measuring in the proximate analysis. So initially we know the boiling point of water is 105. So 105 degrees Celsius is the temperature to remove the moisture content in proximate analysis. Next one is which one of the following is a physicochemical technology used for the removal of organic compounds from wastewater. So in the wastewater, they are asking which method you will be using under the physicochemical technology. So here the fungi is a microorganism and aerobic anaerobic treatment. These are all the biological methods. Only method which is using physical and chemical kind of technology is the adsorption method. Okay. So here the answer is adsorption. I think the answer was different in that answer key, but the right answer is adsorption. Next one is the tanning. Tanning is a process of treating the animal skins and hides to produce what means is leather. This is a very common question. Next, the Fischer-Tropsch synthesis is normally used to convert syngas into what? The answer is liquid fuel. First, what does this syngas means? Syngas is a producer gas. So when we are burning the biomass like wood materials, I'm telling. Biomass is a lignocellulosic biomass. Any wood will have the higher amount of lignin and cellulose content in it. All these are the carbonaceous material. When they are burned, then we will get the carbon dioxide, hydrogen, and also sulfur. And if nitrogen substances are there in some amount, we'll get that also as a vapor, like a gas. And these gases, by adjusting the stoichiometric ratios, we can decide our final gas product by giving the amount of air. We can also use pure air for this process. We can also use pure oxygen. We can also use any other gas substances for the burning processes. Based on choosing this gas substances and based on the stoichiometric ratio, we will get the end product. So while after burning of the biomass, we will get the gaseous emission. That gases are called as the producer gas or syngas. So they are asking after the syngas is produced, Fischer-Tropsch synthesis will convert the syngas into what product they are asking. So the product is the liquid fuel because this FT synthesis is a heterogeneous catalytic process that will convert the biomass derived syngas into the synthetic liquid. So the answer is liquid fuel. Next is the calculation of green index included the sub-index of two variables. So if you see, this green index is used to measure or determine the amount of environmental impact over a city or any region. So for that, this green index is calculated. So while calculating this, other sub-indexes they are including is the SO2, sulfur dioxide, and the COH. So this is the answer. Next is, which of the following condition is favorable to achieve the complete combustion of any fuel? So they have mentioned like combustion. So combustion means anything that is burning in the presence of oxygen, right? For the the word combustion itself telling that oxygen is there, and complete combustion means for the biomass to completely burn, how much oxygen is required stoichiometrically. That sufficient oxygen should be given, or more than that, more than sufficient, excess oxygen can also be given, so that we can ensure that complete combustion of the biomass happens, and all the carbon in the biomass are converted into the carbon dioxide. So the right answer is sufficient or excess oxygen to achieve the complete combustion. Next is the which law is the basis for quantifying the rate of fluid flow through the saturated subsurface materials. If you see, Newton's law will speak about the motion of the solid objects, that is Newton's law 1, 2, 3. And then the Fick's law will describe the process of diffusion. And then the Fourier's law will, deals about the law of heat of conduction. And here the right answer is the Darcy's law. So Darcy's law will deal about the rate of fluid flow through the saturated subsurface material. Next is, which of the following is or the components of gas chromatography system? Answer is all of the above. So the gas chromatography will be having a sample injection unit. After injecting the sample into it, so it will be heating the sample and vaporizing it. And in the column, what happens is, based on its mobility, the compound will get separated, and then the detector. So the detector is going to detect the gaseous compounds, and the output, finally the output of the detector will be the concentrations as the electric signals. So all these three components are present in the GC. So the answer is all of the above. Next, the final question is, which of the following is an advantage of chilled ammonia process for the control of CO2 emission? So in the ammonia process, mainly what happens is the carbon dioxide emission will be very higher. To control that, high CO2 capturing efficiency is very important. So that is the right answer. Next, we will also discuss the sample questions for assignment 1. These are the sample questions to be discussed for the week 1. And in the next week, we will discuss the solution for the assignment 1 of the course running in this year. And then we will discuss the sample question for assignment 2. Okay, this is how this tutorial will go. And so far, do you have any doubt? That ma'am answered on the answer. That ma'am, based on the answer you recorded, the answer from the third question is given to be fungal one. That's the correct answer. Fungi is not a correct answer, because fungi is also a microbial treatment biological process. Physical and chemical means there should not be any biological substances. Basically, how this water treatment process are classified is, first one is the physical method, next one is the first one is the physico-chemical method, next is the mechanical method, next is the biological method. If you see the physico-chemical method, it involves the absorption process, and also the this one, ion exchange processes. All these things will come under this physico-chemical treatment. And if you see the mechanical process, you will use some mechanical force to break down the substances, like a ball milling, like that it will come normally. But in the case of water treatment, it is different. Next, the biological process means that is aerobic and anaerobic. There you will use the aerobic bacteria and anaerobic bacteria to decompose the waste materials. And then the fungal treatment will also be using the fungi. It is a microorganism, so it comes under fully biological. So in this class, only assignments will be discussed. Right now, for this first class, I have taken the notes of assignment 0 solution, and then the some sample questions for your assignment 1. And then I have the tutorials which is given as your lecture 5, which is given in your lecture 5. Okay. Okay. These are the things I can answer. So, you have any doubts so far in the week 0 assignment and the basic concepts? Okay, I'm a research scholar. I'm doing a PhD in National Institute of Technology, Trichy, NIT-Trichy. So, this live sessions will be taken by the PMRF scholars, okay, Prime Minister Research Fellow students. So they will be doing taking the live sessions. So for this course, 3 live sessions are planned. I think my session is allotted to Saturday 3 to 5, and again 2 more sessions will be taken by some other PhD scholars also. It is not like the same person from the IITs, the same person offering the course will not take this live session. So these sessions are taken by the PhD scholars. Okay. You have 3 sessions. You can attend the sessions whenever you are available. So now, can we go to assignment 1, sample question? Can I get some confirmation from you? Are you all there? Hello. Okay, I hope you are all there with me. Coming to the assignment 1 sample question. So match the followings with their correct definitions. So these are all very simple questions. First one is you have to match PQR with 1, 2, 3. First is the species. So the right answer is 2. Group of similar organisms that can breed and produce fertile offsprings. So it is the group of similar organism. That is what species means. So if you take any scientific name, it will be having some genus name and species name. So the second one is the species. So next is the community. Community is an assemblage of different populations that live together. It's a community of different population. Next is the ecosystem. Ecosystem is the collection of organisms that live in a place with a non-living environment. So in the ecosystem, you will be collectively including both the living organism and also the non-living organism. It includes both the biotic and abiotic components. So the right answer is second option, P. Species is 2 and Q is 3 and R is 1. Next, what is trophic levels P, Q, and R in the energy pyramid from bottom to top? So if you see this triangle, so this is the ecological pyramid, right? So what comes in PQR? First is the primary producers. What are the primary producers? We know the answer. It is a simple one. First one is the primary producers. Next one is the primary consumers. And the third one is the secondary consumer. Finally, the tertiary consumer will come. What are the primary producers? What is domain of your research? Okay, we can discuss these things later. If you have any queries in the last 10 minutes, we can ask these general questions. So leave this chat as of now for our course discussion. Okay. Plants. Yes. Yes. Plants, grass. All the plants. Fungi, vegetation. Yes. Good. These are all the primary producers. So these primary producers are eaten or taken by the primary consumers, and again the secondary consumers depend upon the primary consumers. So this is the answer. Next is, which of the following is the correct relation for exposure in risk assessment? We have seen this in the overview, right? So exposure is the product of intensity frequency, and duration. Next is the balanced chemical reaction of photosynthesis. This is also very simple. So photosynthesis equation, 6 carbon dioxide molecules plus 6 water molecules plus energy are all reactor, and then after the photosynthetic activity we will get C6H12O6, which is glucose, plus 6 oxygen molecules in this reaction. Next, if a compound X, I think you have a similar problem in this week assignment also. Um, you can take a note of this. If a compound X has an octane water partitioning coefficient of 110 and the concentration of X in lake water is 0.5 mg per liter, find the approximate concentration of X in the animal at the bottom of all food chains in the lake. So the right answer is 8.16. You all know this formula, right? What is BCF? We have seen it, right? What is BCF? What is BCF? Yes, BC is bioconcentration. BCF is the bioconcentration factor. Okay, good. So now log BCF is equal to 0.79 log of KOW. So here the OW stands for the octane water. So K is the symbol of the partitioning coefficient. Okay. So KOW is the partitioning coefficient of octane water, which is given as 110. So this 110 we have to substitute here. Okay. 0.79 log of 110 minus 0.4. The answer is 1.213. And then we are calculating the log BCF, and then we have to convert it into BCF. How we will do this one? How to convert the log into BCF? Simple. So it is 10 power x. You have to convert log into log BCF into BCF means you have to put 10 power x. So here x is the 1.213. So 10 power 1.213 is 16.32 liter per kg. So now you have found the value of BCF, and what they are asking for is find the approximate concentration of x in the animal. So in the animal, how much amount of x is there? So we know the general formula is here. So BCF is equal to concentration of X in the animal, that is in the living being, divided by concentration of X in the environment. Here the environment mentioned is the lake water. So already the concentration in lake water is given, which is 0.5 mg per liter, right? And we don't know only the concentration of X in animal. We also found the BCF, which is 16.32 liter per kg. Now what happens is, we know we have to substitute all the values. You have to multiply 16.32 into 0.5. So the x value will be 8.16. The unit is mg per kg. Okay. You have to note down these two formulas. These two formulas you have to memorize. First, you need to know the formula of log BCF. From that, you will find the BCF. Then the general formula of BCF is concentration of X in the living being divided by the concentration of X in the environment. So this can be asked in different ways, but using these two formulas, we can find any unknown thing. Next is which of the following is not a renewable energy source? So this is very easy. Tidal energy, wave energy, geothermal energy, and hydro energy. All these are renewable energy source. So the coal-based energy is a non-renewable energy source. Next is which of the following has lowest power requirement for same equivalent brightness? We know that comparing the traditional bulbs, CFLs are better, and the LEDs are so much better than the CFL. So the answer is LED. Now, which of the following phase in treatment of municipal wastewater deals with the removal of coarse materials to avoid the operational problems? So here in the wastewater treatment, which at what phase the coarse materials are removed, they are asking. The answer is pre-treatment. Anyone knows the order of the treatment? Order of wastewater treatment. So it includes these four steps, which is primary treatment, pre-treatment, secondary treatment, tertiary treatment. Can you arrange this? Just 1, 2, 3, 4 mentioned here. Can you give the right order? Okay, it is also given in the week 1. Okay, then it is easy for you to solve it, right? 2, 1, 3, 4. Yes. So pre-treatment, generally what happens there is all the coarse materials, larger particles. So there will be a mesh filter screen, membrane-like filtration will happen. So the grit is going to remove all the larger substances, which is the coarse materials. That is the pre-treatment. Then is the primary treatment. In the primary treatment, we will use methods to divide again the waste materials. In the secondary treatment, you will be using the microorganism to treat the water. And then the tertiary treatment comes. Again, you will be increasing the purity of water by ozonation or using chlorine treatment. Like that, you will be treating it again and again. And finally, the treated wastewater will get released into the river. Next question is, the steps involved in risk analysis are find the most suitable option. So we have seen that lecture 4 deals with the risk analysis, and all these things are included in it. First one is hazard identification. You should be identifying the hazard, and in the identification itself, you have to classify it, like whether it is a human hazard or it is a environmental hazard, like that you have to classify it. Then you have to assess the risk. So risk assessment comes there. Then the risk management, how we are going to manage the problem. Finally, through communication, we will come to a conclusion. So all of the above are included in the risk analysis. Then the process of evaluating the risk resulting from a hazard is known as dash. So the question is the process of evaluating the risk. So how you will be evaluating it? It's a direct question only, risk assessment. But sometimes it is confusing, no? Confusing, no? Like risk communication is there and risk management is also there. With the same word risk, we have three options. If you know all these things only, then you can find the right answer. Here they are asking generally in the risk analysis, what are the steps involved? Each step definition is also very important. You have to read about them. So here you are evaluating the risk. So you know, in the assessment process only, you will be evaluating the risk. Like if it is a human hazard means, then what kind of effect it will be causing in the humans. That is what you will be evaluating in these steps. Okay, now we have finished the week 1 sample questions. Any doubts in the week 1 sample questions? The difficulty of final exam notes are the same, like this are different, other than these assignments. Please answer. Okay. About the exam, only the professors can answer because they are involved in the preparation of questions. But since the syllabus is designed in this way, it will include both problems and also the theory questions. But the weightage of the problem questions and the weightage of the theory question will be decided only by the professors. Even though you are getting the problems, all the problems will be similar to those given in the assignments, or all the solutions can be indirectly there, like all the important formulas will be there in the lectures. Based on the formulas available in the lectures, the problems can be framed. What else? Based on the tutorials, we have some reference problems in the lecture file, right? Some modified problems can also be asked. It is up to the professors only. So this live interaction session is mainly to answer the tutorials we are teaching. These are all extra things, like we are solving some sample questions from previous years, and then we are here to answer the doubts of your previous week questions of this year's assignment. Like today I have discussed the assignment 0, right? Like that I will discuss the assignment 1 in the next week. So that is what this session is for. Exam pattern, you can also ask the questions in the discussion forum, so that you can also get a direct reply from the professor. Okay. 2134, 2134, 2134. Someone have mentioned 132. 2134 is the right answer for the order. Okay. Is there any doubts? Shall we move to the tutorial session, like lecture 5? Okay. I hope there is no doubt. If you have any doubt, please note it down. Finally, I can clarify your questions again. So I have seen the tutorial video also, like all the problems are, okay, thank you. Thank you, Satyanarayana sir. Okay, thank you. I have seen the YouTube video of the lecture 5. So the explanation was there. I have solved all the problems, and if you have any doubt, you can solve with me. Uh, I expect you to solve manually, so that will only benefit you. That is why this 2 hours is for. It is not only I am speaking from here. It will benefit you when you are solving the problem. So I will be there in the online for each and every question I will be answering. First, I want you to work out, and then I want you to ask doubts. If you have doubts, you can ask me. I am here only in the class. I will explain the question. I want you to solve it. Then after some time, I will again answer the question. Which problems? Lecture 5, you have 7 problems for this week. Yeah, in tutorial. Yes, the tutorial, lecture 5. They have solutions, but if you have any doubts in the steps, you have to work it down, right? This is the practice session for that one. Okay, we'll move on to those problems. First problem is compound X has an ether and water partition coefficient which is K soluble of 4. Here ether and water. Last time we have seen the octane and water. It is mentioned as KOW, right? So K is the partition coefficient. Keep in mind, it is a symbol of partition coefficient. Like here they have mentioned like K soluble, okay, instead of KEW. It is a representation given in the question. You can write in any way. So here K is 4, and if 11 gram of compound X, so mass of the compound X is given, 11 gram of compound X is dissolved in 100 ml of water. How many grams of compound X will be in the organic layer after one extraction? So the first question is based on the single stage extraction. So here only one stage you are going to extract. So after one extraction with a volume of 100 ml of ether. So how many grams of X will be there in your organic layer, they are asking. The question is 11 gram of some compound is mixed with 100 ml of water. So now you have that 11 gram in 100 ml of water, and it is passing through a single stage extraction. In that, what is happening is you are adding 100 ml of ether to it, and then you are taking only the ether layer outside of the extraction chamber. So now after the extraction process, how much amount of compound X will be there in your ether organic layer, they are asking. Okay. And then the second question is how many grams of compound X will be in the organic layer after the sequential extractions using the 50 ml portions of ether each time. So this is the double stage extraction, that is two-stage extraction. It is sequentially extracted. Sequential means what? After one extraction with 50 ml of ether solution, again in the second extraction chamber, we are using the another 50 ml. So you are dividing your 100 ml ether solution into two, and you are extracting with 50 ml once, and after extracting the thing, again you are adding the 50 ml of ether. Finally, you have to give an answer for the C question, which of the two extraction is more effective, like process A or process B. How you will arrive at this answer means you have to find the now the question of A and B is to find the amount of compound X in the organic layer. You have to calculate the amount of X in the water also, so that how much amount of X is left out in the water in the single stage extraction process, and how much amount of X is left out in the water in the double stage extraction process. So from this, the amount of X in water should be less. Okay, that is why that process will be effective. Like more amount of compound X should go into only the organic layer. Less amount of X compound should be present in the water. So with that calculation, you can find which of the two extraction is more effective. Understood the question? Problems. Solving section is every week, same day, same time. Uh, it depends upon the PhD scholars, sir. I am taking the assignment 0 and the assignment 1, and I am also adding the tutorial questions in my interaction session. So I am teaching it. So I will be solving the problems every week. My session is on Saturday 3 to 5 p.m. every week. So I will discuss the tutorial problems also every week. In the upcoming classes only, you will get to know how the other scholars are taking it. And then how can we do in final exam? Okay, ma'am, but those conversions, you have to work out. I think you are writing the NPTEL exam for the first time. You will get the rough paper also in the examination hall. We have the digital calculator over there in your computer. You can use the system calculator, and then you can work out in the rough paper, and you can choose the right answer in the system. Okay. Formulas will not be given. All these things you have to think. Yes, like that only. You will have the calculator in your system. You have to use digital calculator. We have 7 problems. I think we have very less amount of time. Uh, so you can take some 2 minutes for working out. If you have any doubts, you can ask. After 2 minutes, I will solve it. Any doubt in the question? Please solve it. Okay. This is the question. Please solve it. I will display the answer slide also. This is the answer slide. If some people are not solving also, please take a look into the answer. And if you have any doubt in the steps, please ask me. Okay, first I will explain this one. Have any doubt? This hazard identification and risk assessment is part of risk analysis. Yes, it's a part of risk analysis. First is the hazard identification. Next is the risk assessment. We have different steps, no? Risk communication, and one more thing is also there. Risk management, and then risk communication. Or all these steps involved in the risk analysis. 4 steps are there. We can refer the lecture 4 also for a brief explanation. Okay. We will look into the solution. First, I will explain this one. So they have given the partition coefficient K of ether and water, which is mentioned here. Concentration of ether and concentration of water. The ratio is K, which is 4. It is given in the question. And the total mass of X, that is weight of the compound X in water, is 11 gram and volume of water is 100 ml. First case A is a single stage extraction and case B is 2 parts with ether. So now I hope this screen is also visible for you. So consider this as a single stage extraction and consider the next boxes as double stage extraction. Okay. So now what is going in here is the 11 gram in 100 ml of water, right? That is what going inside in the single stage extraction. The output here is 11 minus x grams. So 11 minus x gram same water. That's right. In water. So in the single stage extraction, water is going in and water is coming out. 11 gram initially present in 100 ml of water. Finally 11 minus x grams will be there in the water. And now here you are adding 100 ml of ether. Okay. And finally what is coming out is x grams in 100 ml of ether. So here water is called as the water is called as the solvent here. And the organic solvent you are using is the ether. So now in the bioprocess, you will be calling it as the extraction phase and raffinate phase. I don't want to complicate this, so I will go with a simple term. So here, why I'm drawing this diagram is it will be easy for you to know why this K is calculated in this way. So X gram in 100 ml of ether. So how much grams of compound X is there in ether divided by how much grams of compound X is there in the water. That is the remaining raffinate phase, which is not required. So 11 minus X gram. So this ratio, see concentration in the organic solvent, that is ether, and concentration in water. So what is the concentration now in ether is X gram in 100 ml. And then what is the concentration now in water after extraction is 11 minus X. So 11 minus X by 100. So we know that K is already 4. K is already 4 given. X by 100 divided by 11 minus X by 100 is equal to 4. So 100 will get cancelled. And again, if you are solving it, you will get X is equal to 8.8 grams. So this 8.8 grams is extracted in this ether layer. And what is remaining in the water means 11 minus X. So 11 minus 8.8 is 2.2 grams, which is remaining in the water. When you are coming to the part 2, which is the two-part extraction. Okay, someone wants to join. So in this one, what is happening? I will tell. Similarly, these are all same. 11 grams of compound is there in your 100 ml of water when it is going in the stage 1. So this is 1. Okay, this is 1 and this is 2. Here 11 minus X gram will be coming out of the stage 1. Okay. What is the amount of ether inside your first extraction chamber? It is 50 ml, right? It is not 100 ml here. So 50 ml. So again another 50 ml we are adding here. So what is the output here is X grams in 50 ml ether. And again you will get some amount of Y grams in 50 ml of ether. Here, for calculating the left out amount of compound X in water, we have to do 11 minus X minus 1. Now, this much amount will be there in the 100 ml of water after the second stage. That is how this calculation is done. So now the formula is concentration of ether by concentration of water. So the concentration of ether in the first stage is X gram in 50 ml. So X by 50 divided by the concentration in water. So which is 11 minus X by 100. Okay, is equal to 4. So now the X value is 7.33 gram in ether. Amount remaining in water is calculated by 11 minus X. So 11 minus 7.33 is 3.67 gram. And again for the second stage now we are calculating. Concentration of ether here. So it is Y gram. Here it is given as X. I am telling just as Y. Okay. Again some Y gram is leaving the second chamber. And how much is there in the water means it is 11 minus X minus Y. That 11 minus X we have already calculated as 3.67. So that is substituted here. And here I am taking as Y. It is also given as X for both the chambers. Okay. We can keep in any ways. So 3.67 minus X divided by 100 is equal to 4. So from this you will be getting the Y, that is X here, 2.45 gram in ether. So you have to add these two and you have to find it. That is 11 minus X minus Y, 3.67 minus 2.45. So you will get remaining amount in water as 1.22 gram. And the amount extracted in the ether is totally together in X and Y, you will get 9.78. So absolutely which method is superior? 50 ml extraction, two-stage extraction superior to single-stage extraction. Why? Because only 1.22 grams are left out in the water phase. Here 2.2 grams are left out in the water. So this method is better. Case B is better. Okay. Now, coming to the next question. This is very simple. We have solved one previous year problem also same. First, the compound X has octane water partitioning coefficient of 130 and the concentration X in lake water is 0.5 mg per liter. Here find the approximate concentration X in the animal. So we know two formulas, right? One is the log formula and one is the direct BCF formula. BCF is equal to concentration in any living organism divided by the concentration in the environment. So now first we are writing this one. Now you know how much is there in the environment, 0.5. You have to calculate the concentration X in the organism. So you need to find the BCF. For that they have given the partitioning coefficient value 130. So you are using the log BCF is equal to 0.79 log KOW minus zero point 0.4. Here the K value is 130. You are substituting it and you are finding 18.62 liter per kg. And then when you are multiplying the 0.5 into 18.62, you will find the amount of substances that is the concentration of X in the animal living in that lake water, which is 9.31 mg per kg. Is there any doubt so far? Since it is a simple question, I have solved it directly. Are the two problems clear? Okay. Next one is a simple problem with different units. So consider a solution of ammonium sulfate prepared by dissolving 66 grams of anhydrous compound in water and diluting to 1 liter. What is the concentration of this solution they are asking? So it is very simple. First, you need to know ammonium sulfate molecular formula and its molecular weight. You have to calculate, which is 132 gram per mole. And then if you are dissolving 66 gram in 1 liter, what is the concentration of the solution they are asking, but in different units. First unit is gram per liter. If it should be in gram per liter means then it is direct thing, right? 66 gram in 1 liter. So the answer is 66 gram per liter. Next is moles per liter. If you have to find moles per liter, another unit is molarity, which is M. Okay, it is termed as molarity, capital M. So molarity formula is you have to you have to divide the weight of the substance by the molecular weight of the substance. So you are dividing 66 gram per liter with 132 gram per mole. So you will get 0.5 moles per liter, which is also known as 0.5 molarity. Okay. Next is the equivalence per liter. If you are mentioning it in equivalence means then you have to find the normality here. That is what the question is. So to find the normality, you should know the equivalent moles. So to find the equivalent, you should know the ions present in your compound. So for ammonium sulfate, it is 2 only. For either case, sulfate and ammonium, it is 2 only. So you are multiplying the normality formula is molarity into the equivalence. So it is 2 equivalents. You already know the molarity. So you are directly calculating the normality. 0.5 into 2 is 1. So it's 1 normality or 1 equivalent per liter. Okay. Next is gram per liter of sulfate and gram per liter as nitrogen. This is what they are asking. So to calculate this one, first individually you need to calculate the molecular weight of sulfate and also the molecular weight, uh, molarity of the sulfate and molarity of the nitrogen. First, you need to know the molecular weight for this. So this is very simple. If you see the formula NH4 twice SO4. So in this, if there is 1 moles of ammonium sulfate means in 1 mole of ammonium sulfate, how many sulfates are there means only 1 sulfate is there. So 1 mole of sulfate is there in 1 mole of ammonium sulfate. So for the 0.5 moles of ammonium sulfate, how many moles of sulfate are there? This is simple, right? If For 1 mole of sulfate is there. For 0.5, so exactly 0.5 moles of sulfate per liter. Then you are calculating mass per liter. That is what they have asked. In gram per liter, they are asking, which is mass per liter. So you have to multiply the molarity, which is moles per liter, into the molecular weight to obtain gram per liter. So the molecular weight is 96 gram per mole. So you are multiplying it, you will get 48 grams sulfate per liter. Now it is expressed as gram per liter of sulfate. Similarly, you are doing it for nitrogen. Molecular weight of nitrogen is 14 and you are calculating the molarity. If you see the molecular formula, NH4 twice SO4. So this twice is common for hydrogen and nitrogen. So if you multiply with 2 moles of nitrogen are there. 2 moles of nitrogen are there in 1 mole of ammonium sulfate. So in 0.5 mole of ammonium sulfate, there will be 1 mole of nitrogen per liter. So this is how we are calculating the molarity. And again, if you multiply the molecular weight, gram per mole, then mole and mole will get cancelled. You will get gram per liter unit. So you are getting 14 gram per liter nitrogen. So the answer is simple. Now, another question in the same way as we discussed. So the first octanol water partition coefficient KOW of pesticide is 3 lakh. It is given and calculate the bioconcentration factor BCF. Most of the question of this week 1 lecture is around this risk assessment and bioconcentration factors, right? And some unit conversions. Next, BCF they are asking BCF present within the fish to water. So now earlier they have asked what is the concentration in animal, what is the BCF, like that they are asking. Now they are also asking us to calculate the BCF as well as the concentration in the fish. Both we need to calculate. So log BCF is equal to 0.79 into log of KOW minus 0.4. So since K is already given, we have to substitute it directly. So you will get log BCF. To convert it to BCF, you have to put the value in 10 power formula. So the 10 power value is BCF, which is 8451.344. And the concentration of pesticide in the fish, we know the formula, right? BCF is equal to concentration in the living organism divided by concentration in environment. So concentration in the fish is equal to BCF into concentration in the environment, that is water. It is given as 2 ppb. ppb is parts per billion. Okay. So if you multiply this, you will get 16,902.69 ppb, which is the concentration present in the fish. Okay. We have solved 2 more problems. Any doubt? Meeting. So for any doubt? Okay, I will continue the session. So this is another problem. To solve, this is a very simple problem, but you should know some basic concept behind it. How much solid waste is generated in tons per day from Rourke and Meerut if their population are 1 lakh and 15 lakh respectively. So Rourke, you should know that Rourke is a small town and Meerut is a medium town. Okay, then only you can use these formulas. So if you see here, solid waste generated gram per day. The formula for the small town is 100 to 200. Okay. And for the medium town, it has increased, right? 300 or 400. The range is different. So you need to keep in mind whether that city is small town or medium town to calculate these things. Okay. So these are very important. So population into 100 or 200 grams per person per day. So here the population is 1 lakh. So 1 lakh persons are there. So person and person will get cancelled. And again, this much gram per day will be there. You have to convert the grams into tons. So 1 kg is equal to 1000 gram and 1 ton is equal to 1000 kg. So you are dividing it by 10 power 6 to convert it into ton. So the answer is 10 ton per day to 20 tons per day. Next, in Meerut is a medium town. So the formula will be changed into population into 300 or 400 grams per person per day. Okay. So the population here is the per capita is 15 lakh. Okay. 15 lakh into 300 or 400. Again, the gram is converted into tons. So dividing it by 10 power 6. So the estimated amount of solid waste generated is 450 to 600 tons per day. Okay. Next. So this problem is quite different from the previous one. You have to uh, keep in mind several standard values, and these standard values are based on the conditions given in the question. Okay, from the conditions given in the question only, you have to choose the standard values. So you have to keep in mind whether the particular substance is carcinogenic or non-carcinogenic. Okay, the question is when chlorine is used for disinfection of drinking water, chloroform can be produced by the reaction of chlorine with residual organics in water. Estimate the ingestion intake rate for the non-carcinogenic effect. This is very important. Okay. First in the question, you have to find whether that substance is having the carcinogenic effect or non-carcinogenic effect, and it is given as the adult resident. In your lecture, you will have for different person. Maximum they will be considering the adult. Okay. In a home receiving tap water with an average chloroform concentration. So the concentration of chloroform in the home is 75 microliter. Okay. If we are solving it with 75 microgram per liter, then the answer will be 1.8 only. Okay. There is some mistake in this solution. This is the sixth one, right? No. If you are solving it with 75 microgram, the answer is correct. 2.1 it will come. Okay. And then if you substitute 0.065 only, 1.8 will come. There is some mistake in this one. Okay. First, the general formula is I. Intake is equal to CE into RI into EF into ED divided by BW into AT. All these things we have already discussed. Like CE is the exposure concentration. So here the people are exposed to what? Chloroform. So now the chloroform is present in the tap water. So people are intaking the chloroform. So the concentration of the chloroform is 0.075. Okay, it is not 6, it is 75 mg per it is 75 microgram. Microgram, to convert microgram into mg, you have to divide it by 1000. So it is 0.075 mg per liter. And again Ri is the intake rate. The rate is 2 liter per day. Okay, these are all constant values. And then ef is the frequency of exposure. So the frequency is taken as 350. Okay, and then ed is taken as 30 years. And here again you are taking 70 kg average weight of the adult and 365 days per year into 30 years. So finally you will get the I, and HQ is calculated from I divided by RFD. RFD is the reference dosage. So the reference dosage here is 0.01. It is also given. So you have to divide the 2.1 into 10 power minus 3 with 0.01. Then you will get a value of 0.221, okay, which is less than 1. And in the case of 65 mg, 0.065 mg per liter, you will get 1.8 into 10 power minus 3 as I, and your HQ will be so 0.18. Okay. So both are less than 1. If your HQ is less than 1 means, then you can conclude this as the level of chloroform constitutes an acceptable risk. Anything greater than 1 for HQ, it is already mentioned, anything greater than 1 is considered as unsafe. Okay. Any doubts in this problem 6? Do you have any doubt? Actually, the values are changed. Here it is given as 75. It is taken as 65 here. But the answer given is for the 75 microgram only. Here you have to substitute this 2.1 into 10 power minus 3 here for the 75. The answer for the 65 microgram per liter is 1.8. Okay, some confusion is there. You have to work out. But what you have to keep in mind is always the hazard quotient should be less than 1. Then only it is considered as the safer limit. I hope there is no doubt. I'm not getting any reply in the chat box. Are you all with me? Am I audible? Okay. I hope there is no issue with the presentation. Okay. Next one is slightly different. So here it is given for carcinogen. That is the only thing different from the previous question. Okay. So here you will be taking I is equal to C into Ri into EF into ED by BW into AT. Okay. The same thing, but in earlier thing you have the RFT, right? I have already told you this thing in our theory slides. You should always keep in mind for carcinogens, SF slope factor will be given. For non-carcinogens, the reference dosage will be given. For reference dosage, the formula is HQ is equal to I divided by RFT. Okay. And for the carcinogen, you are using the slope factor. So the formula is different. Okay. LCR, lifetime cancer risk, is I into SF. Okay. Earlier, what you have done is I divided by RFT. Here, I into SF. SF is the slope factor. This is obtained only for the carcinogenic substances. Based on the hazardous substance, whether it is carcinogen or not, then the formula will be different to calculate the risk analysis. Okay. So the question is, if benzene, a known carcinogen, is found in air at a constant concentration of 1 microgram per meter cube of air. So they're telling 1 microgram per meter cube. This is the concentration at which the people are exposed to. The calculate the risk for exposure to this benzene for an average adult. So they have given an average adult only. So the body weight is 70 kg. That is fixed. Okay. Who inhales 20 meter cube per day. So their exposure, how much they are intaking is 20 meter cube per day. That is different here. Okay. With 50% absorption for a light. Okay. With 50% they are inhaling 20 meter cube per day. From the 20 meter cube per day, the 100% of benzene is not absorbed. So only 50% is absorbed, they are telling. Okay. So that is a different thing. So benzene slope factor is SF is equal to 0.015 mg per kg day inverse. Okay. So again, this formula is familiar for you all now. I is equal to CE, concentration of exposure. Even though they are exposed to 1 microgram per meter cube, they are telling that absorption rate is only 50%. So here we are converting the CE from 1 microgram per meter cube to 0.5 into 1 microgram per meter cube. Why 0.5 is only 50% is the absorption. Okay. Then RI. RI is the intake rate. So here the rate of intake is 20 meter cube per day. So 20 meter cube per day. Here they have divided it with 100 to convert it into mg. Okay. Sorry, divided by 1000. Next is the ED. Duration of exposure is 350 days per year into 70 years. And again, the body weight is 70 kg and exposure time that is 80 is 365 days per year into 70 years. Okay. Then years and years will get cancelled. And again, here day and day will get cancelled. Year and year will get cancelled. And meter cube will be there. Here the meter cube and this meter cube will get cancelled. And microgram is now converted into mg. only mg is there in the numerator, and in denominator you will have kg, and here year and year will get cancelled, so day is there. So kg day only available in the denominator. The value is 1.37 into 10 power minus 4 mg per kg day. Okay, so this is how the intake is calculated. Now to calculate the lifetime cancer risk LCR, it is I into SF. So SF is the slope factor. Why SF is there means because it is a carcinogen. Okay. If non-carcinogen is there, you will divide I with RFT. So now the slope factor is 0.015. Okay, unit is it is reciprocal. It is given as reciprocal. So they have changed the unit here as kg into day divided by mg, and here the unit is mg divided by kg day. So what happens? All the units get cancelled, and LCR is having no unit. The value is 2.06 into 10 power minus 6. Because it exceeds the 10 power minus 6, so this risk is unacceptable. As I told, the threshold limit of HQ is 1. Okay, if it is exceeding 1, then it is considered as unsafe. Okay, for the non-carcinogen. And for the carcinogen, if you see, if it is exceeding 10 power minus 6, then it is considered as unsafe. Okay, this is the level for the non-carcinogenic substance and carcinogenic substance. So always keep in mind, I is having the same formula, but your risk analysis will be different. For the non-carcinogen, you will be measuring the HQ. Okay, and this is having only the chloroform. If more than one substance is present, then you have to calculate the HQ for different substances. Finally, you have to find the summation of all the HQs. Then you have to check whether that HQ is greater than 1 or not. Here only one compound is given in the question. More than one compounds are there means then you have to add all the HQs and have to check whether it is less than 1 or greater than 1. Now coming to the carcinogen, they will give the slope factor. Then you have to multiply the each I into the slope factor. If it is exceeding the 10 power minus 6, then it is having some potential risk over the environment. So it is unacceptable. Always the threshold acceptable limit is 10 power minus 6. So 10 power minus 6 is nothing but 1 in a million chance. 10 power 6 is million. So 1 in a million chance of adverse effect is the acceptable threshold. Okay. So thank you all. I want to know if you are having any doubts. If you are not having doubts also, I want your feedback. Okay. Yeah. You want me to explain the problem 7 one more time. Okay, Robin. So the question is, if benzene, a known carcinogen, is found in air at a constant concentration of 1 microgram per meter cube. The concentration of the benzene in air is 1 microgram per meter cube. Okay. Then calculate the risk for exposure. Whether it is riskful or not, they are asking. So they are asking you to do the risk analysis. So first, before doing the risk analysis, you have to find what category of substance it is. It is carcinogen. Okay. So risk to calculate the risk of exposure of this benzene for an average adult who inhales 20 meter cube per day. Inhalation rate is 20 meter cube per day with 50% absorption for lifetime. For a lifetime, he is inhaling at a rate of 20 meter cube per day, but the absorption of this carcinogen benzene is only 50% they have given. Okay, here the slope factor of benzene is given. First, the formula to calculate the intake is I is equal to CE into RI into EF into ED divided by BW into AT. First, CE is the concentration of benzene. It is 1 microgram per meter cube. Even though they are exposed to that much concentration, the absorption is only 50%. So they are multiplying it with 0.5, which is nothing but 50 divided by 100. Then this microgram is converted into mg. So we are dividing it by 1000. Okay, 1 mg is equal to 1000 microgram. Okay. So now microgram will get cancelled. Next is RI, intake rate. How much they are inhaling is 20 meter cube per day. We are multiplying with 20 meter cube per day. Next is the EF, exposure frequency, which is 350 days per year, and ED is 70 years. Okay, and the BW, body mass weight count, is 70 kg for an average adult, and 80 is 365 days per year into 70 years. Okay, now, if you are solving this, you will get 1.37 into 10 power minus 4 mg per kg day. This is I. Now you have the I to find the whether it is riskful or not. Since it is a carcinogen, you should multiply the slope factor with I. That is the formula for the carcinogen. If it is a non-carcinogen, you have to divide the reference dosage divide the I with reference dosage to find the HQ. Now it is carcinogen. So you are measuring the LCR. Okay. So LCR is equal to I into SF. Your I is 1.3 into 10 power minus 4 and your SF is given. You are multiplying it and the final value is 2.06 into 10 power minus 6. Minus 6. As I said, the threshold limit is 1. Here the threshold limit is 10 power minus 6. You can easily remember it as 1 in a million chance. Okay. Since it is 2.06 into 10 power minus 6, it is exceeding 10 power minus 6 limit. So this risk is unacceptable. You have to tell this one. Okay. And for some NPTEL papers, they will also provide you the answer booklet. For some theoretical papers and all, I have seen some students writing in that paper, so they will be evaluated. You can confirm this question with the professor in the discussion forum, whether the descriptive answers, like descriptively, you have to solve the problem, or you will be solving the problem in the rough sheet and you will be choosing in MCQ alone. You can confirm this with the professor. Okay. I hope I have cleared your doubts in today's session, and I need your feedback, like whether it is okay, whether I'm fast, very fast in explaining, or it is okay to speak in the speed. We want to discuss any other things relevant to this course. Anything you want me to add in the upcoming classes, or is it okay? Thank you. Okay, I will keep the chats open and meet open for next 2-3 minutes. If anyone is willing to give feedback, you can turn on the mic and speak, or else you can also send your messages in the chat box so I can check and take your feedback for the next class also. I hope the voice is clear and there is no problem with the presentation. Anything with the course content you have, can tell me. Shiva Behra. Okay, problems are explained very well. Everything is all right. Speed is okay. Okay. I'm not convenient in writing in presentation with pointers. Do you want me to solve the problems by handwritten, or the typing is okay? If you want me, I will try to do that from the next class. These are all very simple problems. Okay. If you don't understand, then okay, you want me to write. Okay, I will be prepared for that also in the next class. Thank you. So every week my session will happen in Saturday. On Saturday 3 to 5. Okay. Thank you. Okay. Thank you all. Thank you for your feedback and thank you for joining today's class. Expect you all for upcoming classes also. Thank you.